I would like to cover a few aspects on greener thermal solutions for public buildings in general. And generally, anyway, not the public buildings and commercial buildings, there is a small variation. There is a thin line which divides the two, because the comfort is one anyway. Now, I would like to look at it this way. What are the public building landscape which we are looking at currently? Because in our current scope. And let us see before we look for solutions, what are the identify the existing problems which are there or challenges which are there, or maybe there are some ways by which we can do, and maybe, it is not being taken up, something like that. So looking at it from that point of view, what are the opportunities for energy saving and etc. And then we shall also see what are the smart thermal solutions available and how to achieve operational excellence through technology. Now, while we do this, we will understand that the basics, back to basics is very important, because, thermodynamics has not changed, or the way we do in main water and air, they have not undergone any physical change of physical laws actually. Now, looking at the public building, there are lots of public sector institutions now. Healthcare facilities, we see lots of healthcare facilities. Definitely they need air conditioning. It's not only new buildings, new construction. It's also existing buildings which come up for refurbishment, replacement, which we have to look at. And from that point of view, even the public sector and the institutions. Now, academia, campuses, university, schools, that is again another major area where not everything is air conditioned in a campus, but there are key components of which are air conditioned, because air conditioning in today's context, possibly looking at it from the temperature climate point of view, for a common man, it is becoming like no more a luxury kind of thing. Everybody wants to go for it, but when they go for it, unless they have something affordable, something reachable and simple to install and maintain, they may not go for it. Now, industrial facilities, yes, there are a lot of industries which are there. Government buildings, individual, multiple. Now, here is where advanced planning can be done when we talk about public buildings and government institutions, government buildings, government institutions. Because, unlike private institutions, where, unlike, something like a gift city, where somebody came up with the concept and then the entire circle around that area, it got developed in that kind of an environment. Unlike that, government buildings, they can always interact with them much ahead of time, because there are some central nodal agencies which can work together, and we will see how they can do and what kind of things can be developed going forward. Now, HVAC, we will touch upon because our topic is thermal solutions. HVAC is a major energy consuming component at the end of the day. HVAC, lighting, there are a lot of lighting management systems coming up, lifts. Then HVAC, since we end up having air as a medium at the final point where the cooling thermal comfort is required to move air, to work around air, to provide thermal comfort, you need to spend a lot of energy. That's what we will find here. Now, this slide just shows us comprehensively how the heat from a space here, from a space what we are taking, and how it is transferred from using different medium from air. If we have a chill water system, we pass it on to the chill water. Then we have to engage a refrigeration loop, or we have vapor absorption system or a vapor compression system. Then you have a heat rejection system where we need to pass out this entire heat. And the one thing which connects all of this together is your building automation controls and automation loop, which also has advanced a great deal over a period of time. So this and the technology at which the equipments have enhanced the technology what is available and making it smarter and smarter. That is where possibly using the traditional system, because the system's thermodynamics have not changed, as I said, but we can use the technology to harness, to fine tune, to optimize the energy levels and energy parameters in a building. And we have to understand that each component is a node in the energy equation here, whatever is there. And also we have to understand the systems are more important than equipment, because we have to move away from the equipment saving energy. That will always happen, that can happen, but we also have to look at the system at a broader level. Like as Vikram was mentioning, we generally go with, simply put the ceiling diffusers and cool the entire space. If you have got, 20 feet, 30 feet auditorium, 30, 40 feet auditorium, do you have to cool the entire space? Or can we go with displacement system like how they have done and how they do in the air conditioning? He was showing Chhatrapati Shivaji International Airport and a couple of other locations where underfloor in a library in Europe, underfloor air distribution system, which we think underfloor can be done only in, computer crack units and data centers and all that. So while these systems are there in bits and pieces, we see them getting employed. We don't see them on an average in given any commercial building or a public building. I think they should set examples for all this and start employing the different methods of air diffusion methods, displacement system, underfloor air distribution, and demonstrate the savings in front of the other developers and private institutions, so that they can just be leaders and pioneers in showing that this is how we need to go. I think there is a lot of opportunity, because there are lots of old government buildings which will come for refurbishment, new ones which will keep coming up. There are lots of opportunities for saving there if you go for different kind of systems without compromising on thermal comfort. And then on chill water system design aspect, one is on the air side, because we have to handle air side, water side, refrigeration side, heat rejection side, and then control side. The chill water side, yes, you have various options available. You can go for variable primary flow, series counterflow systems, high delta T systems, heat recovery chillers. And also we have to, I think, more focus has to be there at the ground level on achieving energy savings through proper controls, automation, and commissioning. I think this is one area. And then on the chill water side, on the chiller side, refrigeration side, there are lots of more options available. But do we go for it for every building? No, we are not going. You have high delta T options, series counterflow options. You can achieve much better COP levels, and we can go for it. So I feel the owners have to start asking questions to their designers, whether is this the only option available for us? Do we have any other option? Or do we just want to do, a traditional way of design of chiller? Because today manufacturers, there are somebody from manufacturing side also in the panel today. We'll be hearing very good things from him. There are lots of opportunities which are there. So I think every owner has to ask this question to the designer: do we have this as the only option? Is there any life cycle analysis which can be done? Can we have multiple options? And then you show us that over a period of 5-6 years, there is a return on investment. And after that, it becomes a savings on the bottom line. And then district cooling system, district energy systems is a very important one. And when we talk about public buildings, so this is, I think a loud call which we need to give to the federal government, the central government, and the state governments. Can they coordinate and then plan out the development in the next 5 to 10 years, and then focus on one area for all their buildings to come up? Or old buildings which are more than 20 years old, 25 years old, they want to scrap and move somewhere else. Can they earmark some specified areas and have a district cooling system where you can make use of the diversity, you get much better performance, performing machines. Your cost for per chill water, kilowatt hour, megawatt hour of cooling is going to be much less compared to that. I think that the government's public buildings and institutions have to set as an example and pioneer in this field, because we tried through various means to push private, developers and private entrepreneurs. I think this is taking off. Is unless they see money in there, they will not be able to invest. But whereas government can, public institutions can definitely plan much ahead of time. The coordination among themselves, among the various departments is possible, and they can set an example. And even they come up with this district cooling concept and start selling chilled water to private building owners. I think that should be the trend which we'll see, because going forward, our energy requirement, the electricity power demand requirement is going to be huge. As Vikram was mentioning in the ICAP plan, it is mentioned the kind of cooling needs are going to go beyond 50-60% in the next 10-20 years. Now, unless there is a drawing board, we have a plan, I think all this, will not take place there. So, again, we do have other systems, energy efficient strategies like geothermal, thermal storage, exhaust air energy recovery, and we have radiant cooling systems, earth-air tunnel systems, ground source heat pumps, heat recovery on the chiller front and air front. I think these options should be looked at. Thermal storage is again a very, very good option. And if there are more buildings, going for thermal storage system, maybe we will be able to get the equipment at much better price point when the economy of the business case will become much better and more, feasible for us to go into these kind of systems. And we have to also understand the meter is on the building and not on the equipment, because we are very happy, everybody wants to get the best equipment. I think the equipment building is more important. System consumption, kilowatt per tons are more important. So those are the broad things that I wanted to share with you. Thank you so much.